Today we're going to do day 2 of graphing rational functions. It says here a rational is going to have a hole, which is known as a removable discontinuity. That's the correct math term. A lot of times we'll refer to it as a hole. Wherever a factor cancels from the numerator and the denominator equals 0. So the first thing we would want to do is to simplify this. In order to do that, we need to factor. And so this factors to be x plus 2, x minus 1. And in the denominator, we get x minus 4 and x minus 1. So we factored both the numerator and the denominator. Once we have factored the x plus 2 times x minus 1 and x minus 4 and x minus 1, we recognize that there's an x minus 1 in both the numerator and the denominator. Those cancel each other out, leaving me x plus 2 over x minus 4. Now, when this canceled out, it could still cause it to be undefined since it's still in the denominator. 1 minus 1 would make this 0, and 0 times anything would get 0 in the denominator. That's where a removable discontinuity happens. When something cancels and can still cause it to be undefined, we get a hole. So the x value of the hole is 1, because 1 minus 1 makes that 0. So whatever canceled out, you set equal to 0, and that will give you the x value. To find its corresponding y value, because notice it says write as an ordered pair, we need to use what's left. So I plug in my 1 for my x, and I get 1 plus 2 is 3. And 1 minus 4 is negative 3. 3 divided by negative 3 is negative 1. So the hole on this graph is going to be at 1, negative 1. It looks like this. Like if we took a hole puncher and punched a hole right out of that graph. So it's an open circle that we plot there. Now what's left is what we're going to use to get the rest of the parts. And so our vertical asymptote comes from whatever makes our denominator 0. In this case, that would be 4. 4 minus 4 makes this denominator 0. So my vertical asymptote is at x equals 4. Notice that I put an x equals because that's what makes a vertical line. A vertical line is x equals, and then the x value is 4. So we want to do a vertical line at x equals 4. Don't just write the 4 because then you're going to end up getting it wrong. Now for our horizontal, that's our rules. The Bobo Botno eats DC. So we look at our exponents. The exponent in both the numerator and the denominator is 1. So this is eats DC. Exponents are the same, divide coefficients. So we're going to divide the coefficient. The coefficient of x here is 1, and the coefficient of this x is 1, and 1 divided by 1 is 1. So our horizontal asymptote is at y equals 1. Again, notice that it is y equals. You wouldn't just want to write 1, you would want to write y equals 1 because that's what makes it the horizontal asymptote. For the x-intercept, that's when our y value is 0. So you've got to remember that to get an x-intercept, the y value has to be 0. In order for this y value, because we've got y equals x plus 2 over x minus 4, that's the equation that's left. In order for this to be 0, the numerator has to be 0. 0 divided by anything is 0. So this part right here. So we take x plus 2 equals 0. I subtract the 2. And so we get the x value of negative 2. So our x-intercept is at negative 2, 0. At this point, we really have enough points to go ahead and graph the left side of our graph. Since rationals always approach the asymptotes. So I'm going to go through those 2 points and head towards the asymptote. So we've got that piece there. To find the exact y-intercept, we plug in 0 for x. So the x value has to be 0 for it to be a y-intercept. I plug in 0 here and I get 2 divided by negative 4, which is negative 1/2. Now, since I've already graphed my piece, you see that it does go through that point right there. But we need to figure out what is going on the right-hand side of this graph. So I pick any point to the right of that vertical asymptote. We could pick 5, 6, 7, 8, 100, whatever value you want. The closer you are to the vertical asymptote, though, usually the easier the numbers are to work with. So I'm just going to go to the very next number, which is 5. And so I plug in 5 for my x, because that's how you make a table of values. You're looking for the corresponding y value for that one. So I plug in 5 for my x's to figure out what y is. 5 plus 2 is 7, and 5 minus 4 is 1. And 7 divided by 1 is 7. So there's my point at 5, 7. You can go ahead and graph with that one. You can go ahead and try and get another point. Either way would be okay. If I plug in 7 here, 7 plus 2 is 9. 7 minus 4 is 3. 9 divided by 3 is 3. So at 7, we've got a point at 3. Moves towards the asymptote. As long as you have one point, the sketch is going to work out because you're going to move towards the asymptote, and we're going to go ahead and take that. For the domain here, it is coming from the left. It is jumping over that hole, moves a little bit more, jumps over the asymptote, and keeps going. So our domain would be all real numbers except for the value of the hole, which is 1, and the value of the vertical asymptote, which is 4. So that's our domain, all real numbers except for 1 and 4. All right, on this next part, it says, what is f of 1? And explain your reasoning. 1 we said was undefined there, because when I plug in 1 here, 1 minus 1 would make this denominator 0. 0 times anything is 0, so it gives us a 0 in the denominator. So this is considered undefined, because it puts a 0 in our denominator, and you cannot divide by 0. All right, let's look at another example. And this one's harder just because the factoring is a little bit harder. So I'm going to move to the side and do the factoring first, and then we'll worry about the equation. We need to factor both this numerator and denominator. For the numerator, I can factor out a 3, and I'm left with x squared minus 4x minus 5. And then that trinomial factors to be 3 times x plus 1 times x minus 5. That's going to be our new numerator. For the denominator, we would group our first 2 terms and our second 2 terms. Our greatest common factor out of this first part here is x squared, and I'm left with x minus 2. For the second one, I can factor out a negative 25, and I'm left with x minus 2. Since they both have that x minus 2 term, I can factor that out, and I'm left with x squared minus 25. Now this here should be a pattern that you recognize. That's the difference of 2 squares. It's really important factoring one, and it factors to be x minus 5, x plus 5. Now that we have all that factoring done, we can set up our equation down here. So in my numerator, I'm going to have a 3 times x plus 1 times x minus 5, because that's what it factored to be. In my denominator, I'm going to have an x minus 2, x minus 5, and x plus 5. The x minus 5 and the x minus 5 cancel here. That's where the hole is created. So our x value of the hole is 5. And then we are left with 3 times x plus 1 over x minus 2, x plus 5. In order to find its corresponding y value, I plug in 5 for the x's here. So that's going to be 3 times 6, which is 18. And then 5 minus 2 is 3. And 5 plus 5 is 10. So that's 30. And we can reduce that because 6 goes into both of those, so that would be 3/5. We don't want to leave that fraction without reducing. So that's where the whole is created. I would go to 5 3/5, and there is the whole. Now the vertical asymptote, I take whatever's left, and what makes our denominator 0 would be our vertical asymptote. So we've got one at x equals 2 and one at x equals -5. In this case, we have two vertical asymptotes. Notice that the whole is not over here with the vertical asymptote. If it's a whole, it is not a vertical asymptote. So I'm going to go over to 2, and there is my vertical asymptote. And I'm going to go to -5, and there's my vertical asymptote. And I'll pause this and go ahead and graph it in a second. Let's just focus on the attributes. So what's left of our equation here, this is bigger on the bottom. So when we were looking at this, this is a BOBO. Bigger on bottom, 0. So my horizontal asymptote is at y equals 0. For this one, you kind of need a bigger table of values. You can use the whole here to graph this side, but we need more points to graph the center part and then graph the outside part. So you would want to grab some more points on a table of values. For the x-intercept, again, that's what makes our numerator 0. And so that would be -1. So -1, 0. For our y-intercept, that's where we plug in 0 for our x's. And so that would be 3 times 1 in the numerator. And then when I plug in 0 here, I get -2 times 5, which is -10. So 0 and -3/10. And now I would want to create that domain, that table of values with a couple of points. Before I do that, I'll go ahead and write my domain. That would be all real numbers except for the whole and the two vertical asymptotes. So -5, 2, and 5. All three of these values at some point made our denominator undefined, and that's what our domain is. So I'll go ahead and make a little table of values with a couple points. I would want to pick a couple points here. So -4, for example. I would want to pick a point to the left of that. So I'll go ahead and pick -6, and we'll see if we can graph ours with that. So there it is graphed. Check to verify that that's what yours looks like. This was a hard graph. It had a hole. It had two vertical asymptotes. It had a graph in the middle that crossed the horizontal asymptote. So there was a lot going on this one. You probably won't get one that hard, but I wanted to make sure that you saw one. All right, the last thing we're going to talk about is slant asymptote, and that occurs when the numerator is 1 degree higher than the degree of the denominator. So let's stop and think about that real quick. It says a slant asymptote occurs when the numerator is 1 degree higher than the degree of the denominator. Well, when we were talking about horizontal asymptotes, that right there was the rule of Botno. Bigger on top, no horizontal asymptote. So if there is no horizontal asymptote, that's where could be a chance to make a slant asymptote. But that only happens when the degree of the numerator is 1 degree higher than the degree of the denominator. If it is more than that, then there's not a slant asymptote. So when we look at this right here, the highest exponent in the numerator is 2, and the highest exponent in the denominator is 1. So this is where a slant asymptote occurs. There's no horizontal since this is bigger on top, and this is 1 degree higher than this one. So this is where our slant asymptote occurs. It tells us to find the slant asymptote, we do long division, and we only use the part without the remainder. Now you can also use synthetic division, so I'll do both here just so that you guys can see the difference. It says find the equation of the slant asymptote, and here is my equation. In this case, I'm dividing by a linear factor, so I can use the synthetic. 2 would be my root there, since 2 minus 2 is what makes that 0. So 2 is the one that goes in the top. Then I use my coefficients, 1, 3, and 2. X squared, X, and constant. That's what these coefficients are. I drop the 1, I multiply add, multiply, add. This last number is my remainder. I do not need that last part. The slant asymptote is without the remainder. So this was x squared, x and our constant. So this right here is my x and then my constant. So that is the equation of the slant asymptote. I do not use the remainder. I just use this one. This is something everyone should be able to solve, or graph. It has a y-intercept of 5 and a slope of 1. All right, so let's look at some examples down here. To get the parts, I look at this equation right here and nothing can cancel from the top and the bottom. That means there's no holes. So I write none. Remember, we assign points to all of these, so you want to make sure that you write none. There are no holes. If nothing cancels, there is no hole. Then we look at the vertical asymptote. The vertical asymptote is what makes my denominator 0. That would be x equals 0, since the only thing in the denominator is x squared. This is bigger on top, so there is no horizontal asymptote. We would write none. Don't put 0 because then it sounds like you think there's an asymptote at 0. You would write none in the place if there is not one. For the SA, which is the slant asymptote, we do the division. In this case, we're dividing by an x squared, so we have to use the long division. I'm going to go ahead and put a 0x squared and a 0x in the place just in case we need them. And so I start dividing. X cubed divided by x squared is x. I line that up, I multiply, and then I subtract that. And they cancel. Nothing else comes down until we get to the 1. X squared does not fit in 1, so that's my remainder. So this right here is my slant asymptote. Y is equal to x. That's something you guys should know how to graph because that is the linear parent function. Its y-intercept is 0 and it's got a slope of 1, so it goes up 1 and to the right 1. So here is my slant asymptote. I'm just going to make this with the dotted lines. So there it is. For the vertical asymptote, we said it's at 0. So it's right on the y-axis like this. Just like we do the other ones, we're going to have to get a table of values in order to get some points. You can do that by finding the x and y intercepts. That's some possible points. For the y-intercept, it's not going to hit since my vertical asymptote is there. So there is no y-intercept. For my x-intercept, the only way that this can be 0 is if -1. Can't see that, sorry about that. If we place a -1 here, -1 plus 1 would be 0, and 0 divided by anything is 0. So our x-intercept is at -1, 0. That's this point right here. I can go ahead and graph on that side as I move closer to the asymptotes. That's what makes my graph. Then I would want to get a point on this right side, anything to the right of the vertical asymptote. So we create a table of values, and 1 is to the right of the vertical asymptote. I plug that into my initial equation, which gives me 1 plus 1, which is 2 over 1, so that is 2. And then, of course, I move towards my asymptotes because that's what asymptotes do. They guide your graph. And so there is our rational with that slant asymptote. Our domain would be all real numbers except for our vertical asymptote, which was at 0. All right, there's one more for us to try here. In this case, they made it a little tricky by putting that x cubed second. So this is bigger on top and it is 1 degree higher. I would want to factor this to see what's going on. So I can factor out an x squared. And I'm left with x plus 3. In the denominator, I can factor that trinomial and I get x plus 3, x minus 1. The x plus 3's cancel. That creates a hole. -3 plus 3 would make that 0. What I'm left with is x squared over x minus 1. If I plug in -3 here, it's going to give me 9 in the top and -4 on the bottom. So this would be 9 over -4. There's my hole. All right, to find our slant asymptote, I can go ahead and do synthetic division again. So I'm going to use that 1. My coefficient for x squared is 1. My coefficient for x is 0. And my coefficient for the constant is 0. I drop the 1, multiply, add, multiply, add. This is the equation part since that's the remainder. We were with x squared, so this is x, and that's my constant, so we get x plus 1. Our vertical asymptote is whatever makes that denominator 0. 1 minus 1 makes it 0, so our vertical asymptote is at x equals 1. All right, to graph that y equals x plus 1, my y-intercept is 1, because this is the y-intercept. The slope is 1, so I'm going to go up 1 to the right 1, up 1 to the right 1. I can already see that this is the part that's going to be right here. It's going to be in this section. To get my x-intercepts, I'm looking for where the y value would be 0, which is at 0. So that's right here. So there's my graph on the bottom. For the y-intercept, we already found that it's 0, 0 as well. Our domain is all real numbers except for 1. That's what we're jumping over. I still need something on this right-hand side, so I make a table of values. A point to the right of that 1 is 2, so I'm going to plug in 2 to my equation right here. So that's 2 squared, which is 4, over 2 minus 1, which is 1, so this is 2, 4. And there is our graph. So that allowed you to see some new graphs for rationals. You guys are going to be responsible for being able to find a hole, being able to find a vertical asymptote, a horizontal asymptote, possibly even a slant asymptote, making sure that you can graph them and know what's going on with these graphs.